So in our last video, we learned how to name substituted alkanes that were linear, but now we also need to learn how to name substituted cycloalkanes. So this is overall very similar to linear. For example, this first molecule here, all we're going to do is put our base carbon name. So our base carbon name would be cyclopentane, because we have 1, 2, 3, 4, 5 carbons. So we have cyclopentane. And then we're going to put our name and position of our substituents. In this case, if you say it's at the 1 position, it doesn't really matter because there's only one substituent. There's no relation to anything else. So just for this, in these particular cases, when there's only one substituent on your alkane ring, you only have to say what the substituent is, not where it is. So in this case, we have a methyl group. So we need methyl cyclopentane is the name of that molecule. Maybe we should put it up here so that we know it's that one. Okay, so let's get a little bit harder. What if we have 2 substituents on our cycloalkane? This is when it starts to get tricky, and this is the only kind of harder rule about cycloalkanes. What we have to do is put our number 1 C1 numbering on the number that's so that we get the lowest numbers next to the substituents. So you always start at a substituent. So we could start, for example, here at number 1, 2, 3, 4, 5, 6. However, so this would also fulfill our getting our substituents with the lowest numbers, because then we would have a substituent at 1 and one at 3. However, there's also this other little rule that C1 goes on the biggest substituent. I can't say that word right now. Goes on the biggest substituent based on molecular weight of the atom it's connected to. So we're connected to 2 carbons, but the ethyl group is bigger than the methyl group. So my numbering right here is not completely right. Let's erase it. We're going to start our numbering at the ethyl group, number 1, because it's the biggest substituent. And then we're going to go clockwise around this circle, this one specifically, because then it makes it so that I hit my methyl group in the lowest number, or at the lowest carbon number. Okay, so this is my numbering. Let's identify our substituents. And then we need to put them in ABC order again. So our base name would be cyclohexane, meaning 6 carbons in a ring. At the 1 position, we have an ethyl group. At the 3 position, we have a methyl group. So I put these up top so that I could just put them in order, but E comes before M, so we know that it's 1 ethyl, 3 methyl, cyclohexane. Let's see if this fits. Look at that. It's like pro right here. Ha ha. Okay, so our final answer is 1 ethyl, 3 methyl, cyclohexane. Let's do a couple practice ones. If you feel comfortable, go ahead and try them on your own, but I am going to go through them now. Okay, so our first thing that we're going to do is figure out our base cycloalkane name. So we number 1, 2, 3, 4. So the question here is, did I number this in the right order? I put my substituents at 1, 2, and 3. So that seems good. Number 4 is the only one that's missing a substituent. We have our lowest numbers. And then let's see if our number 1 substituent is the largest. So chlorine is a bigger atom, higher molecular weight than carbon. So yes, this numbering is correct. So we have a cyclobutane. And then let's circle our substituents. We have 1 here, 1 here, 1 here. So let's list these out. We have at the 1 position, chloro. At the 2 and 3 positions, dimethyl. So based off of M and C, because remember di does not count towards the ABC ordering, it looks like this is the correct order. So I don't think it's all going to fit next to each other. So we're just going to move cyclobutane right here. So the final answer is 1-chloro-2,3-dimethyl cyclobutane. Okay, let's move on to the next one. It's a lot harder to write on these iPads than you expect, guys. Okay, so let's number our carbons. I'm going to start my numbering up top. 1, 2, 3, 4, 5, 6. And then let's check. So we're going around the ring. We have substituents at 1 and 2, so that makes the lowest number. And then let's pick and see if number 1 is in the correct spot. So bromine versus a carbon. Even though the isopropyl group is overall bigger, we're only looking at the atom connected to the carbon chain or the cycloalkane. Therefore, this is the correct numbering. Bromine is a bigger atom than carbon based on the periodic table. Let's go ahead and circle our substituents again, so we know what we're talking about. Our base name is therefore cyclo, that's not how you spell cyclo, C-Y-C-L-O, hexane. And then our substituents that we have on here, I'm going to try and make it fit, I promise. We have 1 bromo, and we also have 2 isopropyl. So we're comparing B in bromo and P in propyl because iso does not count towards our ABC ordering. So our ordering is going to be 1 bromo comes first, 2 isopropyl comes second. Guys, I was so close. And make sure we put a dash in between these here. 1 bromo, 2 isopropyl, cyclohexane. Last one, last practice one for this slide. I'm going to go ahead and start my numbering at the biggest thing. We can see that we have a propyl group and that's going to be the biggest. And so I'm going to start my numbering here and go up 2, 3, 4, 5, 6, 7, 8. Biggest group is number 1. All substituents are at the lowest numbers they possibly can be. Check, check. Circle our substituents. I don't think I'm going to fit this one on one line. Okay, so our main cycloalkane name is octane or cyclooctane. Great. And then we have our substituents. Let's write them out. At the 1 position, we have a propyl. At the 2 position, we have an ethyl. The 3 position, we have a methyl. So this might be a little bit counterintuitive. You might want to try and do 1 first, 2 second, and 3 third. However, ethyl comes first in the alphabet, followed by methyl, and then propyl is actually last. So ethyl, 2-ethyl is how we start our name. Got the Y in there. Nope. Got it. 2-ethyl, 3-methyl. So we'll put a dash in between those, show that they're separate. Dash after methyl. And then lastly, 1-propyl cyclooctane. And that's our final answer. 2-ethyl, 3-methyl, 1-propyl cyclooctane. Okay, hope you guys did well. There's lots of these practice problems in your book to try out, and I'll see you next time.